Okay, so battery charger. So most of the time, 90% of people will say, okay, where is my charger? Where is my phone charger? Okay, and you refer to that wall adapter charger. That is not charger actually. That is simply a AC to DC converter which takes your 220 volt main supply and converts to 5 volt USB standard. Okay. But that is not charging your phone, it is supplying 5 volt to the phone from where your battery is getting charged actually. So, the charger is sitting inside your phone, that is not the charger, that is only supplying voltage. So, you can, and most of these wall adapter will have, if you look at there will be a specification printed which will say what is input and output. Input will say 220 volt AC and output will say 5 volt 1 amp or 5 volt 500 milliamp something. Okay. So, 5 volt will always be there because it is a USB standard and this current may vary. So, if you buy more expensive wall adapter, this current may be higher because you do not know what kind of maximum current your phone can support, it all depends on batteries. So, if your let us say phone can support 2 amp, but the wall adapter you have plugged in, the maximum current it can supply to 500 milliamp, then your charging will be very slow in that case. So, if you really want to utilize the full capacity of the battery, then your wall adapter should be compatible with your charger specification. So, your USB has a 4 ports, one is your supply, one is ground and other is D plus D minus. I will come to that actually, I have shown. So, those are data lines and data line is completely different from this, and you can have a dedicated USB cable for charging only, then D plus D minus will not work at all. So, if you connect that cable for communication purpose, it will fail to communicate. So, this takes input from your wall adapter 5 volt and then at the output of this charger your battery is connected and it basically controls the current based on in which phase your battery is. Okay. And when it is fully charged, this will cut off this current and will stop drawing any current from your wall adapter. Okay. So, sometimes some people say, okay, do not keep your charger plugged in for a long time, it will reduce the life of your battery because you cannot, but that is not true. This charger takes care of everything. When battery is fully charged, it will automatically cut off. When I say your battery has a charge discharge cycle of let us say 1000 charge discharge cycles, it is measured with full charge and full discharge. Okay. But if you allow only 10% discharge, after 90% you again plug in, then you can get 10,000 cycle of charge discharge. Okay. And also when your battery is fully discharged, the stress on the battery will be more. Okay. And but when you do not allow your battery to discharge below certain level, then stress on the battery will be low. So, you can imagine if you are charging your battery with a full current for a longer time, then chances of hitting are more, correct. So, the chemistry of battery, chances of changing the chemistry of battery is more at a higher current compared to lower current. So, when you never allow your battery to discharge 0% or so, then you will never leave your battery in a full current phase or full basically 1C phase or 2C, 3C phase, whatever, if it is for a longer time, then you can increase the life of your battery. So, that is why when we say that never allow your battery to fully discharge, that is the main reason actually, it is not any other reason. So, fully discharge and charge because you want to measure the capacity of the battery. So, unless you complete the full cycle, you won't know what is the capacity of battery. So, in order to measure, if I want to measure the capacity of the battery, I have to start with 0. If I am starting with 50%, I will not know what capacity of the battery has. So, you start with 0, okay, let it fully discharge and charge again. So, let us say you empty in your car, if you want to know whether my capacity of my car tank is 40 liter or 50 liter, you have to start from empty. So, empty tank, you get it filled, your meter will tell how much let us say with after 40 liter, it has it cuts off then you will know that capacity is 40 liter. That is what in order to measure the capacity of the battery, you have to fully charge, discharge and charge again. So, that is the main reason actually. Okay. So, wall adapter only provides DC voltage, usually 5 volt in case of USB standard, or it may be higher in case of fast charging. In fast charging it requires higher voltage, and I will tell why we require a higher voltage there, and that will be at a specified current. So, source to battery charger could also be from USB data port. So, when you plug in, and you might have seen, so you can plug in your phone to the wall adapter that has a USB cable, or let us say your computer has a USB port, you plug in that, your phone will start charging, but there is a big difference between the two. That guy will be charging at 1 amp or 2 amp, this will be charging only at 500 milliamp. You can do this experiment, just plug in your phone to your laptop, and you can see your charging rate will be slower compared to what you get with the wall adapter. The reason is USB standard does not allow output current more than 500 milliamp, that is it. So, it will charge only with 500 milliamp. There are a lot of apps where which can tell you how much with what current your battery is being charged actually. So, you can download that app and see the phone itself, you can see how much current is battery being charged, or even if you are not charging, you are running some apps and it will tell you how much current is drawn by your cell phone. So, both you can get from that app. Okay, so USB data versus charging port. So, standard downstream port which is called SDP. So, this port features 15 kilo ohm pull down resistors on both D plus and D minus, these are the data. So, with these resistors it will detect whether it is a dedicated charge port or it is a data port. Okay. So, the cable basically, the cable you are plugging in, whether it is a data cable or it is a charging cable. Even though like same cable can be used for data as well as charger, but if you require a very high current for charging, your data does not require that much current. So, the quality of the cable which is used for data can be much lower compared to what. So, and the cost will also vary. Your data cable, let us say you can buy for 10-20 rupees, but you are looking for a high quality charging cable, it may be 200, 300 or 500 rupees. Okay. Especially if you look for a Apple phone cables, it will be very expensive. Okay. So, then this is from a USB standard itself. So, maximum value of this 15 kilo ohm is 24.8 in the worst case. So, based on these resistors which is connected between D plus and D minus, your phone will detect whether it is a dedicated charging port or it is a standard cable. Okay. And this is very easy to detect the value of, you can just source a current and look at the IR drop, or you can put a constant resistor with the VDD and it will act as a voltage divider. So, that is also you can do. If you have a dedicated charging port, then D plus and D minus are shorted actually. So, you cannot use this for communication purpose. So, in that case it will be only used for charging that cable. So, that cable will not work if you want to transfer any data over USB or anything. So, but it will support much higher current, that is the advantage. Okay. So, then yeah, so that is how you do, and in this case actually you do not even need to run the two separate wires. You can only have two wires which is your ground and supply, because it is a dedicated charging port. So, D plus D minus are shorted. So, these resistors will be mostly connected on the other end of your connector, but your cable is running all the way from your adapter to the other end, correct. So, you can save two wires here and you can make your VBAT, and so let us say in the same thickness I got rid of two wires which is data cable, and I have increased the thickness of the supply and ground wire. So, it can support much higher current So that is why these dedicated charging port do not support these D plus and D minus or data transfer. So, it is capable of supplying your currents beyond 1.5 amp and features a short between D plus and D lines by connecting a couple of 100 ohm resistor between these two. So, this type of port allows for wall chargers and car chargers with high charge capability without the need for enumeration. Enumeration means like when you connect the your USB cable or your USB device. So, it goes through enumeration where it detects what kind of device it is. Okay, it is just a detection of your USB, that is it. Just like when you plug in your USB, so it will detect what has been plugged, whether it is a real USB or device or not, and based on that it will take next decision. Charging downstream port CDP, this port allows for both high current charging and data transfer fully compliant with USB. So, this guy actually can do both things. So, it is a combination of, you can say, high current charging as well as data, and this is a much higher quality cable, you can say. It features the 15K pull down resistor necessary for D plus and D minus communication, okay, just like this. So, you have to support this resistor, pull down resistor, in order to communicate over the cable, and also has internal circuitry that is switched in during the charging detection phase. So, what it will do when the charger is connected, okay, so it will go in the charging phase. When you are transferring the data, then it will basically allow these pull down resistors to be connected. Okay. So, it automatically detects between whether your device you have connected, it is a wall adapter charger or it is a USB data transfer device like your flash or anything. So, USB plug-in detection, when you connect your device or your charger. So, as I mentioned, there is a 15K resistor here with the ground. So, when you connect, you can have a pull up resistor and then you will get a voltage in between. So, between VCC and ground level depending upon, so this will be 15K over 1.15K plus 1.5K. So, it is pretty close to your VCC, slightly below that. Okay. So, this is low speed device, and if you have a full speed device, so the only difference is in this case resistor is connected to the negative port and the resistor is connected to positive port. So, depending upon where the resistor is connected on the device, it will be detected as a low speed or high speed, because in the USB you have a two standards, low speed or high speed. High speed USB is like 400 Mbps or so. This guy will be 12 Mbps or so, very slow speed. Yeah, you can say that actually, as a standard is improving, but usually what happens, higher standard is back compatible to the previous standard. So, that is when you build a host controller, actually it has to be compatible to everything. So, your device can have a different, but your host has to support everything. So, when we say low speed device and full speed device, that means they are two different devices actually, and you can relate that to your USB standard obviously. So, 1.0, or because as standard is kept moving, your speed is increasing. Okay. Now, you have USB 3.0, that is much higher speed. So, this is how your charger IC looks like, and the core of this charger is a buck converter. Okay. As I mentioned earlier, like everything is built around your DC-DC converter. All your advanced power management systems are built around DC-DC converter. So, the core is DC-DC converter, which takes the 5 volt from your wall adapter, and since the role of this is to supply a constant current. So, this works as a constant current, just like your LED driver. So, LED driver, what it does, it supplies constant current to LED. So, we need to sense the current for that, and we looked into the for camera flash, so it is quite similar to that, you can say, and camera flash was drawing like 1 amp and you need to sense the current. So, sensing can be done either by external, but in battery case accuracy is more important actually here. When you are charging with the full current, then if battery does not allow to charge above that, and you want to maximize the charging current, then you have to make sure that it does not crosses even 1% higher. So, that is why accuracy is very more important. Accuracy is more important here. So, in order to get a very high accuracy, most of the time you put external sense resistor, because that is most accurate, small 50 milliohm roughly, and you sense. So, this is your VBAT capacitor, and that is where your battery will be connected on VBAT. Then this is your thermistor terminal, obviously, which is connects to the thermistor, and so this is your battery actually. So, it has a BAT plus, BAT minus is ground, then other terminal is your, which I mentioned, the BTH, you remember, and the fourth one was your BAT ID. So, in this case BAT ID is not shown, because this looks like a 3 terminal battery. So, this end is connected to battery, and then from battery you have a series resistor and you are sensing. So, this will give you the current sense. So, the voltage across this resistor is fixed, very accurate. So, whatever voltage drop you get across this, from there you can measure the current. So, that you can regulate. So, this will be fed back. So, this voltage will be fed back to the controller, and that will modulate the duty cycle of this to make sure the current remains constant. After that, everything is like a standard voltage mode buck, which we discussed in previous topics. Okay. So, there are a lot of other things in your charging. We know that it has to maintain a lot of phases. It has to go between, like, switch between your constant trickle charge, then your pre-charge phase, then constant current, constant voltage phases. So, it requires a lot of comparators actually. That is why you see too many comparators here. So, for thermal shutdown you need, because you need to detect the voltage across that thermistor and then take the decision. So, you need again compare it with some reference. In order to enter to from constant current to constant voltage phase, you again need to compare the voltage. When it is fully charged, again you need to compare the voltage, okay, because everything is based on voltage levels. If you see here, this guy, if you are between this to this voltage level, then it will be your full maximum current. If you are above this, then you are basically you have entered into a voltage constant voltage mode. Below this, you will be in the pre-charge phase, here you will be in the trickle charge phase. So, lot of comparators are needed here. So, it's that is what it is actually. One band gap, you can generate tap multiple voltages based on your requirement, and then after that everything is done by the DC-DC converter. Okay. Then you have a switch here also, which so this switch remains open when your charger is not connected. This only closes when your charger is connected, okay, because you don't want to allow a reverse current or something from there. So, and there is one more reason actually, I will tell you. In some cases we allow a reverse current, but that is a separate purpose, which is in next I will talk about. But this will only turn on this switch when you plug in the charger. So, it will detect that charger has been plugged in, then it will close the switch and then start running this buck. But if you are not charging, then you do not need to run this buck. So, there is something called reverse boosting actually. So, what happens, let us say in one case I am charging, other case let us say I am connecting. So, let us say in this USB port you can connect so many things. Charger is one thing, and charger is sourcing the current, but let us say you have connected headphone on this USB. So, headphone is taking power from here. Not all the cell phones have 1.5 mm jack. There are USB headphones also, lot of USB headphones are there, you would have seen. You haven't seen USB headphones? Go and Google it, or to go Amazon you can buy it. Okay. So, the reason was, like earlier they were willing to get rid of the 1.5 mm jack and connect everything to USB. Okay. But the problem with that is, like when you are charging you cannot listen to music. So, that is why decided, but in between there were a lot of like USB supported headphones which can be connected to this micro USB or So let us say you connect any USB device to this. I mean, that is not the only headphone. There are other devices, accessories for the cell phone which can be connected to USB other than charger. Okay. So let us say you connect a flash drive here. Okay. Just like in the computer, you connect to the cell phone. This flash drive, where will get the power from? They get the power from USB port itself. They do not have any battery as such, these memories. So and this is a charging port, your phone. Now, if I connect a device here which needs to be powered, then it has to be powered from the phone again, and that power has to come from this guy. So, again as per the USB standard, this voltage should be 5 volt, and my battery maximum voltage is 4.5 volt or so. So, it needs to be boosted. So, now, and if you remember when I explained the boost converter, how I explained it, you just interchange the input and output. That is what you do, that is what we call reverse boosting. So, when you are charging, this acts as the input port, where it is supplying 5 volt from your wall adapter, and your inductor is supplying current to the battery. When you are connecting a device here which needs to be powered, you close this switch again, and now your battery voltage becomes input and this becomes output which is supplying to the device. So, you are boosting your battery voltage whatever level it could be, it may be 3 volt, 3.5 volt, but you have to maintain 5 volt here on the other side. So, it will work like a boost converter in the reverse boost mode. So, the same converter can be used for buck or boost. So, the advantage you are saving one converter here, because you cannot charge when you are connecting a device, it is only one port, you can use only for one purpose, you cannot use for multiple purpose at a time. So, when you are charging, it will act as a boost, buck, and when you are connecting a device which needs to be powered, you will boost it, basically put it in the boost mode. That is what we call reverse boosting. And it can be used for any other purpose. Internally also you can utilize it, not just for the external device. Let us say internally your flash requires 4 volt or so, your camera flash requires 4 volt, then again it needs to be boosted. So, in that case you can just utilize this when you are clicking a picture or anything this, but in that case if you are utilizing for internal purpose as a boost, then when your charger is plugged in, during the time you are utilizing for other purpose, charging will stop actually. So, but if you are for camera purpose and all those, it is not a very long duration. So, you can use the main purpose here is like I want to save one converter here and use this single buck converter for multiple purposes, that is it. Okay, so there will be a tiny controller inside which will basically decide when to enter which phase, everything, USB detecting, battery plug in plug out detection. So, let us say you do not have a battery and you plug in your charger, so it will not charge anything as such. So, you have to detect the battery presence also, whether battery is there or not. So, there is a battery insertion detection, battery removal detection, charger insertion detection, charger removal detection, everything is mostly done by this charger. So, a lot of functionalities are integrated around this buck converter in the charger.
So, battery charger design means you design the converter portion?
Yeah, you design converter portion, and around that you design all the controller. No, not DSP, it is a logic actually. It is not DSP. These are simple logic. You are not doing here a lot of processing or filtering here, that is not required. There is no as such a big huge algorithm running here, that is a part of your BMS, battery management system, which does Coulomb counting and everything. So, in that case, so there is a separate one more IC which we call BMS or battery management IC. So, what that does, so here sensing is being done in order to make sure that you are charging at a proper current which is required by the battery. But there is one more sensing is required for the BMS, battery management system, which basically measures the capacity of the battery. So, that is a separate portion, there you require a lot of processing actually. So, you need to do Coulomb counting and everything, take this data, okay, run then you have to map that into a proper battery model and determine the state of the charge. So, when you are measuring the battery capacity or level of the charge battery, then lot of processing is required there. So, that is a part of BMS. So, you have to build a complete algorithm there, but most of the time that algorithm is part of software actually. You do not build those in the hardware, because you already have a processor on your phone. Why do you want to put lot of processing in that device? So, you can save lot of hardware. So, most of the time the measurement portion is there and all the processing pushed into your processor side and in cell phone itself, and that is a more logical. I mean, you already have a high capacity, so high processing unit here, then why do you want to use a separate hardware in order to do the same job, until unless you require autonomous actually. But most of the time your cell phone is running, you do not want to measure battery capacity when cell phone is off. So, that ends your charger. So, and that was the last topic of this PMIC course. So, the main intention of this, if you remember my the other lectures were mostly like step by step, more detailed explanation, and this advanced lectures were like a very brief introduction. And I already mentioned in the starting of the lecture that we will be briefly talking about this advanced, because in order to cover in detail we need a complete one more course. If you want to, even if you want to talk about the charger, we require few weeks actually. It cannot be covered in 1 or 2 lectures. Or if you want to talk about display power supply, how to design step by step everything, then again it will require. But the main purpose here was like how to design a regulator, that was covered in detail, linear and switching both. Even giving a time span, we cannot cover the detailed design of all types of converters. So, that is why we covered only buck converter, not boost converter. Buck boost converter we briefly covered. So, the idea was here like you know how the buck converter is done, okay, and build the foundation of your DC-DC converter, and then from there you can easily basically promote your knowledge to other types of converter. So, as long as your basic concept is clear. So, that was the main purpose of this PMIC course. So, hopefully in future we will try to introduce one advanced level course which will talk about in details all these advanced power management systems. Okay.